Graphing radical equations, example 6. In this example, let's start off with something like y is equal to negative square root x plus 1 minus 3. I'll do my xy plane. I have to figure out where my vertex would be. So I look under the radical at the radicand. To undo this, what value creates 0 when x is negative 1? Keep the value on the outside. Note that we have a negative on the outside of the radical. The negative on the outside says we're looking to graph the lower portion of the parabola that's been moved onto its side. So I locate the point negative 1, negative 1, 2, 3. That's my vertex. With that vertex, I need to be opening to the right because this is positive, but I need the lower portion of the parabola. Again, this here is positive, the x is positive, so I know it's opening to the right. So I go down 1, right 1. That puts a point right there. If I go down 2 units from the vertex, I should go right 4. So I got 1, 2, 3, 4. That'd be a point here. And I'm going to do one more. I'll go down 3 units, right 5, 6, 7, 8, 9. Now, I'm graphing those rather quickly. I guess I should explain that a little bit better. When I'm graphing this and I'm counting, I'm always counting from that vertex. So when you see me pick up and I go 5, 6, 7, 8, 9, it's because I've already counted 4 units from wherever my vertex is. I'm not counting necessarily 1, 2, 3, 4, 5, 6, 7, 8 here. I'm counting from wherever my vertex started, going 9 units. And now I connect my dots. As I connect my dots, I can then identify the domain and the range. I have a domain. Domain just says collection of x values. The leftmost x value for this graph is activated at negative 1. So I say negative 1 to positive infinity. The range, collection of y values. How low can you go on the y-axis? You can go as low as you want because you have this going down like this forever. So you say negative infinity, comma, and then it goes up all the way up to this value here at negative 3. So we call that negative 3 with a bracket. That's what we're representing there. Now, I'll do one more example. We'll call our example 7, and we'll say y equals the square root of 4 minus x plus 1. Y equals the square root of 4 minus x plus 1. So we'll do our xy plane. We look at this, we have to undo the radicand. What creates a 0 there is when x is 4. Keep the value on the outside, so 1. I need to locate the point 4, 1. 1, 2, 3, 4, 1. Then I have to ask myself, what am I working with? I have a positive on the outside, which means I would be graphing the top part of my parabola. Because the negative x is under the radical, it means you need to go leftward. And so I'm just going to graph the top part of the parabola as it opens to the left. From the vertex, I can go up 1, left 1, up 2, left 4, up 3, and that should be 5, 6, 7, 8, 9, a point right there. And I'll connect those points, showing that this is a curve. So there's my radical being graphed, my domain. The lowest x value that I could find would be negative infinity, and it would run all the way up to 4. I'll Put my bracket there because I can contain 4. The range, well, the lowest y value I ever get to is 1. But this thing will go up forever, so it'll go all the way up to positive infinity. And there we have 7 examples of how to graph radical equations. I think you'll have a pretty easy time with it. This is not a crazy difficult concept. So we're looking at our graphing radical equations.